Today we're going to look at a special type of geometric series called an infinite geometric series. And this is when you are looking at every term in the series on and on forever, never ends. There are two different types. One is convergent, and that's when the series has a finite sum. Even though there's an infinite number of terms, when the ratio or the absolute value of the ratio is less than 1, the terms will eventually approach 0. So when you add them all up, you will get a single sum for all of these terms. The other type is divergent. That's when the common ratio or the absolute value of the common ratio is bigger than 1. So the numbers continue to get bigger, so there is no sum. The formula for the convergent series is first term all over 1 minus the common ratio. And again, if the common ratio is bigger than 1, or the absolute value of it is, then there will not be a sum. So our first example is just determining whether or not the series is convergent or divergent. So we have to figure out the common ratio. Part A, if we take negative 12 divided by 4, we get a common ratio of 3. That doesn't really hold for this one, so we'll just pretend that's 36. And we'll say that this is divergent. Our second example, 1 divided by 10 is 1/10. The absolute value of that ratio is between 0 and 1, so this would be a convergent series. A couple of examples practicing finding the sum. So as a reminder, the sum, and notice there's no subscript this time because we're adding all of the terms, not the first 12 terms. So the sum is term 1 all over 1 minus r. So to find the common ratio in this one, I'm actually going to use fractions on this just to remind you how fractions work and maybe build a little bit of number sense. So I did 1.2 divided by 3, converted that so that it didn't have a decimal by multiplying by 10 over 10, and then simplified to 6/15. So that's our common ratio. First term is 3, so we have 3 over 1 minus 6/15. Without a calculator, 1 is equal to 15/15. So when I subtracted those, I got 9/15. To divide fractions, we multiply by the reciprocal. Here's our divide sign. So I'm going to copy, dot, flip, or multiply by the reciprocal of 9/15. 3 goes into 9 3 times. And 15 divided by 3 is 5. So if you grab your calculator and you want to double check me, put parentheses around your 1 minus 6/15 so that your calculator follows appropriate order of operations, and you'll get 5 as well. All right, one more example, and then we're going to move on to the next section. So this time we're just looking at the sigma notation. So notice this time that k starts at 0. So our first term will be when we substitute 0 in for k. And then this, hopefully you're familiar with the infinity symbol. So this just says it's an infinite series. So same process. Our sum is t sub 1 over 1 minus r. When we put 0 in for k, we get 1. Anything to the 0 power is 1. And the common ratio, as you can tell, the base of our exponent is 1/10. So 1 minus 1/10. I'm going to use the fraction again. 10/10 minus 1/10 is 9/10. And when you multiply by the reciprocal, you get 10/9. If you were to punch that into your calculator using the original formula, you would get a decimal of 1.1 repeating. And that is it for this lesson. We're going to move on to 12.5 in the next video. 12.2.